Okay, I'm gonna sum it up for you. We're looking at the world right now, and incidentally, River Falls is approximately, yay, right there, that point. And these are swirling galaxies. Anyway, so once upon a time, about 450 million years ago, sometime in the Ordovician, when River Falls was actually covered over by a sea, and all of a sudden, one day, probably on a Tuesday, this meteor comes in from outer space. Well, actually it goes and then disappears. Oh no! Did you see that? I didn't see that. What? Anyway, the meteorite impacts Earth, and this big, huge, atomic explosion. This is like 6,300 Hiroshima bombs going off all at once. A-bombs, atom bombs. You have this big, huge cloud of debris that's coming up, and hurricane force winds, like if you remember seeing at the skate park. So these hurricane force winds are like, maybe not all around the Earth, but there was actually like a big, huge fireball that came up, and it kind of like incinerated everything that was around it. But maybe it fizzled out because it was in an ocean. You never know. Anyway, this is the map view of the crater that was created by this huge impact coming in. Whoop! Whoop! Yep, so then the impactor disappeared. There's this central uplift that came up, and it's this old rock, and it's surrounded by this younger rock. So how does that happen? Why is this old rock peeking out through the younger rock? Well, let me show you a little schematic diagram over here. Okay, so once upon a time, in the Ordovician sometime, there was actually this happy sun. See, happy, happy. And anyway, so there was this, the oldest unit was that actually this yellow stuff right here is the oldest unit. So this is normal flat line strata. The law of superposition says that the oldest unit is on the bottom and the youngest unit is on the top. So that's normal, right? And then we go to figure 2. Oh, there's an impactor coming! A meteor from outer space! So, actually, it was probably like a meteor from the heavens, and it's like, oh my god! And then it impacts the Earth and creates this huge, well, it starts to create this crater. Anyway, so you'll notice that the sun is watching all this, and it's kind of progressively getting sad. Oh no, Earth, sad day. So anyway, the sun is kind of sad that this impactor, this huge impact comes in from outer space. Oh no! And all those little, those arrows right here are actually the shock waves that are radiating. Like when you hit something, see all those shock waves? Well, you don't because they're shock waves. You can't see them. But they're radiating down through these strata, these flat line strata. So all of these stratas are getting like jumbled up and like mixed up because these shock waves are going back through them. And so it's kind of like if you're in a bathtub, right? And you have a drippy faucet, and this drip comes down from the faucet, and it goes bloop. And so what you see, if your eyes were like flashing at milliseconds, you would see this crater formed, and then these shock waves are propagating down through these layers, right? You're probably bored with this figure right now. I kind of am. So these shock waves are going down, but at the same time, these waves are shooting back up because they're hitting this bedding layer here. So they're shooting back up towards the impactor, and they're creating these rarefaction waves. So the shock waves go down, the rarefaction waves are reflected back up because they're hitting these beds of different densities. So all of this stuff is actually getting pulled up. Just like when that drop of water hits the bathtub surface, it's actually going to create a little crater, and then it's going to have like a little uplift. So if you could slow down a drop of water, you could see that it had an uplift right after it hit the water. It's like the Earth is the water, and a drop of water just hit it. You know, this meteor from outer space. Anyway, these flatline strata are now getting like pulled up through the center. So you can see that this was the oldest unit. Oldest, youngest. So this is the oldest unit down here, and this is the youngest unit. So these units are actually getting pulled up and flapped over. These are going to create these flaps, and all this debris is like flying out. This older debris and this younger debris is getting mixed up. And then we have figure 5 here, which is the end of when the crater is formed. So this is a cross-section of the crater. And so you can see that the oldest unit has now been pulled up through the center. It's creating this central uplift. And then we have these flaps, these little, these strata that got folded over. And then there's probably like an ejecta blanket of all this other, crud that was flying out from the center there. So these flaps are created, and I kind of drew like a little a map view here. So if you reference B to B prime, you can actually see this is the map view here, B prime. So this is as if we're looking straight down at it versus sideways. So this map view is what you can see right here. This is the map view of the crater. Then this is eventually, this happened like 450 million years ago. A lot of stuff is going to go over the top of it. Like glaciers are going to come in about 150,000 years ago, and they're going to scrape the top of this off, and they're going to plane it off. So here I drew figure 6, which is just erosion is planing off the top. So we actually don't have the topmost layer anymore, but we do still have this slump material that actually was in the skate park. I don't know if you remember, Dino just kind of slid down and got slumped in there. So now you can see that the oldest unit is at the top, and it's just juxtaposed right next to this young stuff. Up here in figure 1, happy sun, we have the oldest on the bottom and the youngest on the top. But down here, the oldest is right next to the youngest. So that's kind of weird. If you were walking along and you knew what rocks look like, and you're like, why is this young unit right next to this old unit? You'd be like, something catastrophic happened here. Perhaps it had something to do with a meteor coming in from outer space. Yep, so that's the Rock Elm impact crater. Doo-doo-doo. If you are interested in impact mechanics, there's all sorts of stuff that you can go find. Like NASA would probably be a good website to check out. Also, anything by Eugene Shoemaker is probably a good read. And there's also this thing called the Earth Impact Database, which is just a listing of all the craters that are scientifically proven to be craters for the most part, that have impacted Earth at some point or another. This really cool crater is up by Sudbury, Ontario, and you can see this breccia layer just all throughout Canada. Well, not all throughout it, but in a radius of some length. And so, I don't know, I advise you to start crack-a-lacking and go drive to these places and see these cool things like the Rock Elm impact crater.